Welcome to the video lecture for Chapter 2 on organizing data. This is Part 1, a review of some of the things that we've talked about in class. The first thing that we talked about were variables and how to classify them. It will be helpful to you to be looking at your handout, which looks something like this that you received in class. This will also be posted to the web course, so you'll be able to get a copy of that if you need it. I've also typed in some of the answers for the blanks, and we'll be flashing back to this occasionally, so you'll be able to see that as we work through the video. The first thing we talked about were variables and ask what they are. A variable is simply a characteristic that varies from one subject or experimental unit to another. A variable could be either qualitative or it could be quantitative. A qualitative variable is based on a category. A quantitative variable is based on a number. Let's take a look back at our handout, talk a little bit about some of those details. A qualitative variable is based on a category. Examples of that would be something like the color of a marble, a person's country of origin, or perhaps the flavor of ice cream. Quantitative variable is based on a number, but you want to be a little bit careful here. It has to be a number that measures or counts something. Examples would be weights of an object, the number of children in a family, something like that. The reason we do need to be careful is that numbers can sometimes be used as labels. If that is done, it does not automatically make the variable quantitative. Let's take this example. Suppose we were classifying dogs, and we considered them as being in one of three categories: registered with papers, pedigreed, bred pedigreed but without papers, or just plain mutts. Well, we could label those as categories 1, 2, and 3. The type 1, 2, or 3 is not then an example of a quantitative variable. It's really a qualitative variable in disguise. We're simply using the numbers as a label. A good way to tell that is to think about whether the averages make any sense without this context of knowing that the categories are labeled 1, 2, and 3. Suppose we got an average of 2.3 for the type of dog. Does that mean anything if you don't have this extra information of the first category being 1, the second being 2, and the third being 3? Well, it really doesn't, because we could achieve a different average by simply reversing the way that we're numbering the categories. For instance, we could call the registered dogs a 3. We could call the pedigreed without papers dogs, those could be a 2, and the mutts could be a 1. Well, if we did that, we would get a different average, and therefore, without knowing the scheme of labeling, the average of categories for dogs that we inspect simply wouldn't communicate anything on its own. Now, variables could be either discrete or they could be continuous if they are quantitative. So back here, a discrete variable is one that can only take on certain separated values. Counts are good examples of that. You could have 0, 1, 2, 3 children in a family, for instance. It doesn't make any sense to say that a family has 1.8 children. Continuous variables, on the other hand, can take on any value within a certain feasible range. Once in a while, there is some debate about whether we should call a variable discrete or continuous, but we'll get to that in just a moment. Back to our handout. For continuous variables, let's take the example, say, of looking in a working in a machine shop. We could cut off some pieces of steel. Now, could we cut a piece of steel that would be, say, 2.3 inches long? Well, yes, we could. What about 2.35 inches long? Yes. What about 2.318743 inches long? Well, in principle, yes, we could achieve all of those lengths, as long as we have the machinery that's capable of that kind of precision. So any values within some feasible range are possible for lengths, and therefore we would say that the length of the pieces of steel that we are Cutting would be an example of a continuous variable. It's helpful to see how variables are organized in this classification scheme overall, and that is this: all variables are classified as either qualitative or quantitative. A quantitative variable, on the other hand, could be either discrete, meaning that only certain separated values are possible, such as counts, or it could be continuous. Anything within a certain feasible range is possible. This is a good example to test our skills on classifying variables. Let's look at these data here. What we have is a list of members of transportation committee in some columns then represent all of the variables. The variables would be, we could say, representative, or perhaps the name of the representative, the party that they represent, the term that they're in, or the number of miles, and the number of miles of road in their district. So for instance, Bill Jones represents the Democratic Party. He's in his first term, and there are 231,844.4 miles of road in his district. Back to our handout, we'd like to answer these questions then. What are the variables? The name of the representative, the party, the term, and the number of miles in the district. Which of these variables are qualitative? Well, that's pretty easy to answer. The name of the representative and the party are definitely qualitative because they are not represented by numbers. Which are quantitative? In this case, both the term and the number of miles are definitely quantitative. Which are discrete? Well, when we come to discrete and continuous, it's at this point that a little bit of controversy is actually possible. For the discrete variables, this much is clear. The term is definitely discrete. Bill Jones is in his first term, Chris James is in his second term. It would not make any sense to say that Phyllis Smith was in her 1.3 term. That could be 1, 2, 3, etc. Non-integer values would not make any sense there. Now, what about miles? Well, probably most people would consider the miles variable to be continuous. The reason is that we are measuring values that are on the order of 250,000 to 1,000,000 miles, and those are measured down to the nearest 10th mile. Such fine distinctions are essentially continuous to most people's way of thinking. On the other hand, let's take a look at the first entry here. In Bill Jones' district, he has 231,844.4 miles in his district. Now, that entry could be a 0.4, it could be a 0.5, but apparently 0.42 is not allowed in this representation. And therefore, some people could argue that this is a discrete variable, since not every value within a certain feasible range is achievable. Nevertheless, most people would say that these measurements are, for all practical purposes, continuous, and I think that's a perspective that we would want to take. All right, the next part of your handout talks about organizing qualitative data, and we'll get to that in part 2 of the lecture. Thank you very much for watching part 1.